So next topic is classification of buses. So basically I have stated that I have 4 parameters with me, P, Q, mod V and delta in the last lecture, and into this class we are going to see what is the classification of buses, and we will see first what exactly a bus is. Bus is nothing but the meeting point of various components, or I can also say that the way we are going to call node at in electrical circuits, the exactly similar way we are going to call bus in power system. That is, it's just a meeting point of various components, and I have stated as earlier that each bus has 4 different parameters, that is P, Q, mod V and delta. Okay, so all these 4 quantities will be linked up with this particular bus over here, and not all the 4 quantities will be given or specified. Only any 2 values of the particular 4 quantities or parameters will be specified, and the other 2 quantities we need to find out. Okay, so based on what 2 parameters or quantities are being specified, these buses are classified into 3 types. Okay, like for a particular bus, if PQ values are given, then it is called as one type of bus. If P and V values are given, then it is called another type of bus. Okay, so based on which 2 parameters are being specified and which 2 parameters we need to find out, based on this particular point, the buses are being classified into 3 different types. The first type is called as PQ bus. The name itself states that we have 4 different parameters and it is PQ bus. That means the values P and Q are specified, and mod V and delta values are needed to be found out for this particular PQ bus. So specified quantities are PQ and buses to be determined are mod V and delta, and this bus is also called as load bus. In any power system, we have a generating station. This is load and this is all a transmission line. Okay, so at a generator we have few buses, and we have few buses at load and few other buses in between. Okay, so this buses, PQ buses, are majorly present at loads, and so we are calling these buses as load buses. At loads, only P and Q values will be specified, and hence these are called as load buses. In generally, if we take a power system, we have only one generating station and power will be supplied to n number of loads over there. So obviously number of generator buses will be very less when compared to load buses, as we have only one generating station. Therefore almost 90% of the total buses in power system network are called as load buses. Okay, so PQ bus is also called as load bus, and PQ are specified terms, V and delta are to be determined quantities. The next bus is nothing but PV bus. That means out of 4 quantities, P and V values are specified and Q and delta values needed to be find out or to be determined. And as I have said, this is also called as, PV bus is also called as generator bus or voltage controlled bus. Okay, so why are we calling it as generator bus is, this bus is present at a generating station, and we have very less number of generating stations when compared to loads, and hence number of generator buses are also very few when compared to the remaining buses, that is load buses. Okay, so PV bus is also called as generator bus or voltage controlled bus. So this is PV bus, and now coming towards this slack bus. Slack bus is also called as a reference bus or a swing bus. Okay, so the values that are specified in these 4 parameters are V and delta values are specified over here, and P and Q values needed to be determined over here. Okay, so in generally power system is classified into 2 buses only, to be very frank. One is at a generator and the other one is at load. Okay, but if I need to inject any power into this particular circuit at any point of time in order to clear a fault or in order to clear any disturbance that has occurred in the system, then I need to inject these powers from any one particular bus, then I am going to consider that particular bus as a reference bus. So hence we are going to study about reference bus. But if you clearly observe, there are only two buses, one is generator bus and load bus. So I am going to inject power in either of these two buses only. That means I am going to consider any one of load buses or generator buses, and I am going to call that as reference bus, as I am going to inject real power or reactive power into the power system through that particular bus. Okay, so over here specified quantities are V and delta, and to be determined quantities are P and Q. So in generally we have to consider any one existing buses out of load bus and generator bus as a reference bus. But in majority of the cases we are going to inject this P and Q values at the generating station, and as I am calling it at the generating station, then that means that we are going to consider generator buses specifically as reference buses. Okay, so in most of the cases we are going to consider generator buses as reference buses, and reference bus are also called as slack bus or swing bus. And I am just tabulating all that stuff. I have three different buses: generator bus, so PV and Q delta; load bus is PQ; slack bus is V and delta. So this is all about classification of buses.